Hello, AP Stat students. This is Mr. Hazelhorse coming to you live from room A08 at Papillion La Vista South High School. Today we're going to go through a little information on how to display quantitative data with graphs. We're going to look at some very simple graphs, dot plots, stem plots, and describing distributions. Now, before we jump into today's lesson, we need to be very clear here that we are switching gears to quantitative data. Up to this point, we've been working with categorical data. So all that information we've covered up till now, that kind of stands alone in its own separate category, and we kind of have to turn the page and again realize, okay, we're going to be focusing on how do we best display numerical data, all right? And so let's jump right into this and begin with some dot plots. So a dot plot is a very simple type of graph. We just simply take a number line, and every time we have a data value, we place a dot above the appropriate spot on the number line. So the example that I have in the video here is the number of goals scored in games by the U.S. women's soccer team in the year 2012. So you can see, very simple. They had one game where they scored 0 goals. They had a game where they scored 14. 4 was the most common number of goals that they scored, as we take a look at that, that value having the most dots. So these are an extremely simple graph to create. They're very easy to read and interpret. And they're a type of graph that we're going to see pretty often as we work throughout AP Stats. Now, anytime we look at a graph, we don't create graphs just for the sake of creating graphs. Really, the reason that we create a graph is that we want to be able to analyze and describe the overall distribution of the data. Statistics is really about looking for patterns, and graphs allow us the first step in the analyzing of data, and a very simple process to analyze graphs that we want to walk you through. All right. So anytime we create a graph, our next step will be to examine that distribution. And I want you to remember the acronym S.O.C.S. All right. Anytime we describe a distribution, there's going to be 4 things that we want to identify. All right. And that's where the acronym S.O.C.S comes from. Now, we're going to go through those 4 things, but you'll see they're not going to quite go in order. The reason why we throw it in there as S.O.C.S is it just makes it easy to remember. All right. So the first S that we want to take a look at falls underneath the idea of looking for an overall pattern in the data, and we want to describe its shape. Now, there's a lot of different words that we can use within our statistical language to describe the shape of a graph. If we think about cutting the graph in half, all right, and both left and right sides of that graph are roughly symmetric. We're going to be very loose with our interpretation of our words here. So if they appear to be about mirror images of each other, we call that a symmetric graph. Now, another type of word that we could use, we might call it right skewed or left skewed. You've probably heard those terms in other classes here, and we'll illustrate that as we take a look at some graphs here in a moment. All right, but if it's right skewed, that means that the right side of the graph is much longer than the left side. And if it's left skewed, we reverse that, okay? Another set of terms that we can choose from is we're going to look at the peaks of the data, all right? We're going to almost think of it like a mountain range. So if there's one clear peak, we refer to that as a unimodal set of data. 2 clear peaks is bimodal. We could continue on this trend and say trimodal and quadmodal and so on, but once we get past 2, we just say that it's a multimodal graph, all right? So the first S in S.O.C.S represents shape. Now we're going to skip over the letter O and come back to that. The C represents center, all right? We want to describe approximately where the median of the data would fall. Now, we haven't talked about the term median up to this point, but I hope you remember from previous math classes that the median is the middle data value if we put all the data values in order, all right? So that's kind of what we're trying to use to approximate the center, all right? The S, or the second S in S.O.C.S, stands for spread. And we want to approximate the range within which a majority of the data lies, okay? And we'll give you some illustrations of this as well, all right? So we've got the S, the C, and the S. Let's go back and pick up the O. The O falls underneath a category of departures from pattern. So we want to look at the overall pattern, and we also want to look for departures from the pattern of data. And we've talked about this term before, a good old term of being an outlier. All right, do we have any data value or values that stand out from the overall pattern of the data? Now, not every data set will necessarily have outliers, so don't go trying to search for them. If they jump out at you, it's a good chance that they're going to be an outlier. All right, so that's where the acronym S.O.C.S comes from. Anytime I ask you to examine a distribution, I expect you to comment on its shape, its outliers, if any, its center, and its spread. So let's go through an example and see how this would work, all right, if we're going to examine a distribution. So let's go back to our distribution of goals scored by the U.S. women's soccer team. So if we take a look at this distribution, again, we want to examine it in 4 different areas, okay? Shape, outliers, center, and spread. Now, as we jump into AP statistics, one thing that I have to be very clear on here is that this is going to be a lot different than other math classes that you have taken, and that I'm going to expect you to actually write out sentences and communicate, and I know it's going to be rough, but we're going to get lots of practice on it by the end of the semester and the school year. You're going to be really good at communicating statistical knowledge. And so that's going to begin here. When we talk about describing the distribution of goals and we analyze the S.O.C.S, we're going to write out each of those 4 categories with 4 simple sentences, okay? So let's start out with shape. Now, when we take a look at this distribution of data, a couple things should kind of jump out at us. Sometimes I'll take and just sketch out a rough shape of the data. So if I do that here, all right, we kind of have a single peak, right, which means we would describe it as unimodal. My center here is probably going to fall at about 3 goals. So that's about where my median is. So when we talk about left sides, right sides, we're talking about the left and right side of the center. So we wouldn't call this symmetric by any means. And we can see here that the right side of the graph is much longer than the left side of the graph. So that tells us that this graph is right skewed. So I'm going to write that up in a sentence, all right? I would say the dot plot is unimodal and left skewed. Now that wasn't that difficult, right? We can write that out, okay? So there's our shape. We've described the shape. Now let's talk outliers, all right? In this data set, we definitely have a couple of data values that fall outside of the overall pattern, right? Most of our data values are clustered on that lower end, the left side of the graph, but we have data values of 13 and 14. So we might say something along the lines of we see 2 unusually high number of goals scored in 2 of the games. One game had 13 goals and one with 14. So again, not a ton of writing, but we're going to communicate what we're seeing in the data. That brings us to the center. Well, we already kind of identified the center. We're just going to simply say the center of this distribution is approximately 3 goals. We haven't done any calculations, right? That's just our impression as we look at the data. So again, very simple sentence to write out. And then finally, we have our spread. Now, when I look at this distribution, I want to kind of comment on 2 things here. I'm going to say that in a majority of the games, the U.S. women scored between 0 and 5 goals, right? That's that cluster on the left side of the graph. All right, but their overall range was from 0 to 14 goals, okay? So we want to recognize that there's kind of a big gap if somebody's just reading what we've written about the distribution of goals scored. So if I ask you to describe or examine or analyze a distribution of data, meaning a graph, all right, those are the 4 things that I expect you to comment on: shape, outliers, center, and spread. We can remember them as its S.O.C.S. We want to look at the S.O.C.S of the graph. And again, I expect you to use good statistical language. So you can see here we use terms like unimodal and left skewed, outliers, we've got a center, that sort of thing. All right. And again, write sentences. So that's dot plots. That's describing a distribution. What we want to finish up with today is the idea of a stem plot, which is another very simple type of graph that we can create. So here's an example that we're going to use, all right, to create a stem plot. So it says, how many pairs of shoes does a typical teenager have? A random sample of female students from a particular school provided the following data. And we have 20 numbers there. So We got some ladies with a lot of shoes. All right, some of you might be able to relate to that. Now, the easiest way to define a stem plot is really just to look at one. So let's walk you through the steps of how we're going to create a stem plot. And there's 4 steps to creating a stem plot. All right. So the first step is that we want to identify the stems. Second step is that we're going to add leaves. Third step is we're going to order leaves. And the fourth step is to add a key. Now, when we use the term stems and leaves, you might be wondering, okay, what in the heck is that? So let's take the last number in our data set, the number 51. Okay. So if I take the number 51, let's break that down into its stem and its leaf. All right. So the leading digit, and sometimes we may have multiple digits, that will represent our stem. And the last digit in our data set will represent its leaf. All right. So really, we're just taking a number and we're breaking it up. All right. So if we kind of give you a visual image of each of these steps, when we list out our stems, all right, in this data set, we need stems from 1 to 5 because our lowest data value is 13, and our largest data value, if I remember correctly, is 57. All right. So we need stems of 1, 2, 3, 4, and 5, representing 10s, 20s, 30s, 40s, and 50s. Our next step is then we're going to go through our list of numbers, and we're just going to assign leaves to their appropriate stems. All right. And when we do that, we should get a picture similar to this. And you can see we're starting to see a distribution of data. Now, just to help us out here, we want to go ahead and order those leaves within each of their stems. And so our final stem plot is going to look like this. Okay? And you can see the leaves are ordered. And if I take a look at this, kind of turn my head to the side a little bit, we can see its distribution begin to emerge. All right? If I look at this set of data, I might describe it as bimodal, right, as I kind of draw that line around it. Our center is probably going to fall somewhere in the upper 20s. And so as I take a look at this graph, if I shifted it, we've got, again, another right-skewed graph. The right side appears longer than the left side. But again, just like our dot plot, we can analyze its shape, outliers, we don't appear to have any here, its center, and its spread very easily. And it's a simple graph to make. Now, one thing that we want to make sure that we include on every stem plot is a key. So if somebody looks at this data, we can represent decimal values and values to the hundreds or the thousands or even larger within a stem plot. So we want to make sure that we provide a key so that people interpret the numbers correctly. And so this would be our key on this problem. All right. We would say the number 4/9 represents a female student who reported having 49 pairs of shoes. We always need to give meaning to our graph, just like when we talked about bar graphs. I didn't mention this with the dot plots, but we should always label things. All right, we don't want to confuse or deceive people with how we've created our graph. We want to be clear. Okay, and so that's how to create a stem plot. And it's very, very simple. Now, stem plots also have some modifications that I want you to be aware of. So let's take a look at another example of a stem plot. All right. So this stem plot is representing the heights. If I take a look at the key, right, it's the heights of males in centimeters. All right. So I could pick out any number in there. So if we took the stem of 18 and the leaf of 3, I know that's representing a male who's 183 centimeters tall. Okay. Now, if I look at this distribution of data, it's kind of condensed together. We don't really have a large range, and all that data kind of seems clustered right in the middle. And so one of the modifications that we'll use oftentimes is we'll split stems. Okay. And so in this example, what we're going to do is exactly what it sounds like. Instead of having the stem 15, we're going to have 2 stems for 15 and 2 stems for 16 and so on. All right. So again, the data is still representing the same way. We haven't had to change our key at all. But I want to make one note here that's very important. Again, this is used to spread out data. But when I split those stems, when I use the first stem, this is representing leaves 0 through 4. And my second stem is representing leaves 5 through 9. All right, so each stem covers the same range, just as when I use it as a single stem. In a single stem, each stem could represent a range of 10 values, right? In a split stem, if we split it twice, we would represent ranges of 5, all right? And that pattern holds true with the 16s, the 17s, and the 18s. And if we look within those splits, you can see those leaves in the appropriate stem, okay? And so that's a simple modification that we can use, and you can see this gives us a little different picture of the distribution, right? Now, when should you split? When should you leave it original? You know, that's kind of a gray area, and that's just a decision that you get to make, all right? Second modification that we want to be aware of is what's known as a back-to-back stem plot. And what this allows us to do is to compare similar types of data. We can almost add in a categorical variable to our quantitative graph, right? So our original stem plot was representing the heights of males, and now you can see we've added females to that as well, all right? And this allows us to compare the male and female distribution, and we can see that they are very different in terms of their distributions of heights. Males have a much larger spread within their data. Females are a lot more clustered together. Males would have a higher center overall. The male data appears to be symmetric, while the female data would appear to be left skewed. And so again, this is just a simple way that we can compare similar types of data. And this is a modification that we'll see oftentimes as we work throughout this class. So these are some things that we want to be aware of when it comes to stem plots. Well, that brings us to the end of our video for today. As always, I want to remind you to complete the form below the video, communicate any questions or things you'd like some further clarification on, and we'll take care of those once we get back to class. So I hope you guys are having a great day, and we'll see you soon.